It's about to get passed, probably.
What's
Okay.
the pass?
That's for race.
So, here we go.
Based in college admissions.
So here's where you're at right now. So what you all did yesterday is that all you took was straight acetic acid. Okay? That's all you had. Boom, that's it. Did the titration and pH. Now, I'm not going to ask you to do this, but what you should be able to do, by the way, the next quiz is going to be on Monday. Okay? So, quiz on Monday, quiz on Monday, quiz on Monday, okay? Just telling you.
Chemistry.
I don't know, Shakespeare. So, for example, like what you're going to be able to have to do is like step-by-step titrations where I go, you've added 10 milliliters of a base, 20 milliliters of a base, 30 milliliters of a base. That's going to be the main emphasis of it, okay? And then I'm going to give you, instead of having to know the strong acids or weak acids, I'm going to give you a list and you're going to have to identify, hey, is this a strong acid? Is this a weak acid? Is this a strong base? Is this a weak base? Okay? So you don't have to write out the names of the formulas and the names. You just have to know what they are. Evan?
Can you go over weak and strong bases again, like the difference?
Strong bases are going to be hydroxides. Okay? That's it. So your weak bases will be something where you have the capacity to give up, like, NH4, for example, okay? That could act as like a weak acid and give up. Your NH3 could react with water and form NH4, okay? So that's the main difference. So if it's a hydroxide, it's going to be a strong base. If it's something with, look for a bunch of hydrogens on it, that's the simplest way. That's the short version. Okay. Now, here's the deal. So, realize what happened yesterday. You titrated this with hydroxides. And what was happening when you did that titration, you're going to say, okay, initially it was HA plus hydrogens and anions. So, when you initially had that, even though that was a 0.1 molar solution, the pH was not 1. The pH was much higher than that because of the fact that this didn't ionize, okay? So on that blue sheet, okay, which is a set of questions, the first thing you want to do is calculate like a theoretical pH based upon a molarity of your acid. You should sit there and be able to go, oh, that's 0, 0, minus X, plus X, plus X, old school. Okay, that's what y'all did yesterday. You kept track of pH, and if I had, and you're going to eventually plot this out, and you're going to start, what was somebody's like initial pH, like 2.8, something like that?
3.4.
3.4. Okay, so your pH curve is going to start whatever that is. And then it's going to go along, climb, 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 boom, spike, and something like this, okay? There you go. That's what, you're going to plot that. Now, you're going to plot all three of these titration curves on the same graph, okay? So you can say, okay, this is my non-buffered solution, okay? There you go. Now, what you're going to do today is that you're going to do the other two titrations. The first one, I tell you how much mass of sodium acetate that you're going to add. And that's going to be that 0.0373 grams of sodium acetate, okay? At this point, this thing is going to become a buffered solution, okay? Because of the fact that you're going to add the salt off of the anion. This becomes a buffered solution. So what you want to do on calculation number 1 down below, you want to calculate the theoretical pH of what this is going to be once you add the acetate ions to it, okay? So on this one, on C1, listen to me. There is no hydroxides involved. This is before you add any hydroxides. This is going to be, hey, what's that pH going to be before you add any hydroxides? So do not, when you write the reaction, add hydroxides at that point. You will later on. You're just not going to do it then, okay? There you go. When you get to calculation 2, This is where you want to mix up a pH solution, a buffered solution that's going to start with a pH of 6. So the only way you can do that is go to that Henderson-Hasselbeck equation, plus a log of your anion concentration divided by the concentration of your acid. You want that pH to end up at 6. You're going to know that number. You're going to know the pKa of acetic acid, 4.74. You're going to know that number. You're going to know the concentration of the acid, 0.1. You're going to know that number. This is your unknown variable. But that's going to be, once you find that, that's going to be remembered in molarity. That's a square bracket, okay? But that's moles per liter. I don't want to mix up an entire liter of this solution. I want to only mix up 25 milliliters of it, okay? So, before you go too far down a rabbit hole of pain and suffering, come up, when you get that mass on calculation 2, ask me if it's right or wrong, because there's no point in doing that if that calculation is wrong, okay? So, on the blue sheet, you have a whole bunch of questions to answer. Now, the other thing that you're going to need to do on the back side of that blue sheet, this is not a quantitative thing in terms of like a certain value, but what you're going to do down here on this bottom of this blue sheet, you're going to figure out how many grams of ammonium chloride are required to produce 25 milliliters of a 0.2 molar solution. Again, if you're not sure if that's right, ask me and I will tell you. Then you're going to go, how many grams of sodium acetate would be required to produce the 25 milliliters of 0.2 molar solution? Again, you're going to have those masses. Then what you're going to do over here on this back side, you're going to take a very clean, like washed out, thoroughly clean 100 milliliter beaker, you're going to add 25 milliliters of deionized water. You're going to add that. So what you're going to do is you're just going to measure the initial pH, and then you're going to add that salt to it and see what happens to the pH. Does it go up? Does it go down? Okay? And that's all I'm asking. How much did the amount of pH, how much did that pH increase or decrease? Okay? You're not doing a titration. All you're saying is, hey, I'm going to add this. What did the pH do? Then you're going to do the same thing. You're going to use that same one, rinse it out, add 25 milliliters of distilled water. You're going to add the sodium acetate to it, and then you're going to see what happens to the pH of that. Again, is it going to go up? Is it going to go down? Okay? So those are the ones that you have to actually do in the lab. So what you want to do, don't worry about everything else. You can do that at home. So what you want to do today, add that, the amount of sodium acetate that I tell you to, generate that pH curve. Figure out how much sodium acetate you have to make a 6 pH, a buffer with a pH of 6. Get that one done. Do these calculations on 9 and 10, what those are, add that, mix up, see what happens to the pH. Everything else is just based upon calculations. So that's the stuff that you have to do in the lab today. Got it? Good, Grand? Let's go do science.